Hello and welcome back to another past paper. This time it's paper 1 from February-March 2024, and this is for IGCSE and O-Level Computer Science. Okay, as you're aware, you are going to be sitting two papers. This is paper 1 I'm going through now, and then we've got paper 2. Both papers worth 75 marks, so it's 50% and 50% for each one. But paper 1 is all about topic 1 to 6, all about the theory. Okay, no calculators are allowed. It's externally assessed, and we try to answer all of the questions. The paper lasts 1 hour and 45 minutes. Okay, I think I've tried to whiz through this in about an hour. As you can see here, this is what should be on the front of the paper. Paper 1, Computer Systems. Okay, obviously the date, 2024. Okay, the syllabus. It's out of 75 marks, as I've said. Yeah, and again, no calculators for this are allowed, despite there being some hexadecimal and some binary questions in there. Okay, we'll get started. So let's start with question 1. Computers represent different types of data in binary. A. Tick one box to show the reason why computers use binary to represent data. Okay, well, is it A? Computers only allow ones and zeros to be entered. Well, computers use a language called binary, which is all ones and zeros. It's the only thing that the computer can read, but this is to be entered. Now, I've not seen many keyboards with only 2 keys on, so it's not that one. Okay, computers are made of switches and gates that can only be on or off. That is the correct answer. It's not like a gingerbread house where a computer is made of light switches and gates to your house. It's actually switches. It's something called transistors. Okay, I'm just going to check the other two. Binary does not need to be converted into other formats of data to be displayed. Does not need to be converted into other forms. Doesn't really make any sense. Both computers and humans can quickly process binary data. The answers are a little bit obscure, but the correct answer is B. Okay. One form of data is characters. The American Standard Code for Information Interchange, or ASCII, denary number for the character N is 78. So the ASCII value for N, is 78. And tick one box to identify the ASCII denary number for the character Q. Okay, well, N equals 78 and O, P, Q. Well, it's 4 letters in, so 79, 80, 81. So value for Q would be A, 81. Give the binary number for the ASCII denary number N. Okay, we've got some working space here, so let's have a little look at this. So we know that N is 78. So N is 78, okay, which equals, I'll put that in there so we don't want that to be our answer. So 78, so let's have a little look. Working space, 1, 2, 4, 8, 16. Then asking for it in 8-bit. 32, 64. Okay, I'm going to do it in 8-bit, 128. So none of those, one of those. 78 minus, minus 64 equals 14. So none of those, one of those, one of those, one of those, one of those, and none of those. So that would be the answer. 0, 1, 0, 0, 1, 1, 1, 0. Okay, will give us the answer. Explain how the word red is represented using a character set. Well, red obviously is a sequence of letters, but each letter in the sequence is represented by a denary number. E.G, I think the R, if I look back here, would be PQR would be 82 equals 82. Each letter is unique. Okay, I think that was gives 2 marks. Yeah, there we go. So that would be part 3. Now move on to question 3. Sound can be represented as binary. Explain why recording sound with a higher sample resolution creates a more accurate recording. Well, if I try and draw this for you. Okay, so not very good, but it's a sound wave. If we sample at a low resolution, we're basically taking a snapshot throughout the sample. Okay, equal distance apart, but we're taking different samples. So this would be a low resolution where the samples are fairly we're taking maybe 10 samples a second. Whereas a high sample resolution, we would have the lines or the samples, the snapshots, a lot closer together. Okay, so that would be a high resolution. Each one of these would be a snapshot of the sound, basically measuring where it is on this particular line. To explain, it takes more detailed. I'm going to put in snapshots, yeah, of the sound wave, yeah, enables the capturing of tiny changes, yeah, from this bit to this bit in sound, leading to more realistic, sort of closer to the original realistic sound. Okay, so based on this, part 2, give one other way that the accuracy of sound recording can be improved. Well, it's basically this again. So we're going to basically increase the sample rate. Okay, increase the sample rate. So we move on to question 4. A computer is a central processing unit, a CPU. The CPU includes the registers, the program counter, the PC, the memory address register, MAR, the memory data register, the MDR, the accumulator, ACC, and the current instruction register, which is the CIR. The table contains 5 statements about the role of the registers in the fetch, decode, and execute cycle of the CPU. So basically we've got a statement about each one. Okay, 2 of the statements are not correct. Identify the letter of each incorrect statement, suggest a correct statement for each one. Okay, well, let's have a little look at this. A, PC stores the address of the next instruction to be accessed. The PC, well, that's a program counter. It does store the next instruction, yes. It's counting the instructions and it's storing the next one as we go along. The MAR, the memory address register, stores the instructions of the program that is running. Well, no, it doesn't. It stores the address, so that's no good. The MDR stores the data passed to it from the PC. No, that's not right. The MDR stores data which is passed to it from the MAR, basically telling us where that data is, where its address is, but that's coming from one of the buses. Okay, so that's not right either. So I think that's 2, but we'll just check the others. The ACC stores the result of each calculation, yeah, because that's the accumulator. And the CIR stores the instruction currently being executed, and that's right too. Okay, so it's got to be B and C. B stores addresses, not instructions. Okay, and then C, okay, data is from the address in the MAR, not the PC. Okay, not the PC, not the stores the address of the next instruction. Okay, because we're talking about data. And then B, for 1 mark, the computer has a single core 3.5 gigahertz processor and 8 kilobytes of cache. State what is meant by a 3.5 gigahertz processor. Well, basically 3.5 represents billions, basically 3.5 billion instructions per second, not addresses. Okay, 3.5 billion instructions per second. Question 5. The CPU is changed to a dual-core 3.5 GHz processor. Explain how the number of cores affects the performance of the CPU. It increases, obviously, the performance. Okay, and then if I go back to the other part, up here, okay, more instructions carried out per second. Okay, sort of same thing, but there we go. The amount of cache is increased to 64. So basically, is it doubled? Oh no, wow, it's gone from 8 to 64. Explain how the amount of cache affects the performance of the computer. Again, it's exactly the same as this. It improves the performance. Okay, and because cache is another form of memory, but a high-speed memory, because we're increasing that, it means we're not having to use the RAM to access this data. So it should be access instructions or, I'm going to put this down, frequently used data instead of using RAM memory. Okay, so improves the performance, accesses instructions or frequently used data, quite important, instead of using RAM memory. Good. Another 2-point question. The computer has both primary and secondary storage. Random access memory, RAM, is one example of primary storage. Describe what is meant by RAM. Okay, well, RAM is somewhere you don't go and store your files. It's what's known as volatile memory. Data isn't saved when computer is turned off. How many does it want? Describe what. So that's 1. It's basically storing. It is storing data which is currently in use. Okay, so that gives us 2. Read-only memory, ROM, is another example of primary memory. ROM often stores the startup instructions for a computer. Identify one other item of data that is commonly stored in ROM. Well, ROM usually has the firmware for the computer. Firmware controls how device functions. Okay, you might have heard of it as well, BIOS. Okay, but I think for that I'd rather use firmware. Some computers make use of virtual memory. State the purpose of virtual memory. Stores used data when the RAM is full. Stores used data when the RAM is full, basically when the RAM has run out. Okay, that would give us 1 mark. A computer has an operating system, an OS. Complete the table by writing in each missing OS function name and description. Okay, so we've got function name, managing memory, then we've got blank, and then managing peripherals. So we need a description for managing memory. How does an operating system manage memory? Okay, managing memory is allocating memory, RAM, for various processes or operations. So allocating memory RAM for various processes operations carried out by the CPU. Okay, allows application software to run on the computer. Well, this is weird, isn't it? Well, what a horrid question. Because basically, and I must admit, I've referred to the mark scheme. I would have dropped a mark on this. Allows application software to run on the computer. Well, I would have put a GUI, graphic user interface, environment, so people can click on different applications, whether that's on a Windows PC, whether that's on an iPhone, whether it's on an iPad. And I suppose it's a similar thing, but what the actual mark scheme does say is platform for running applications. But in my mind, that's a little bit too obvious. I would have said it's a graphic user interface environment displaying the app icons. Okay, managing peripherals. Peripherals being hardware, so that sends and receives data from hardware. E.G printer. Okay, so that's how I would do it, and of course it's I before E except after C, so that would be EI. Okay, so hardware sends and receives data from hardware, e.g. a printer. Part B, state the purpose of an interrupt. A pause, which indicates a problem or something requiring attention. Okay, state the purpose of an interrupt, a pause which indicates a problem or something requiring attention. And then part 2, identify one input device and one example of an interrupt that can be generated. Well, they've chosen an input device. Obviously, the easy one is an output device, because a printer would just send a signal back to say, I'm out of paper, or there's a paper jam. But we've got an input device. Now, thinking about input devices, we've got things like mice, keyboards. Why would either of those generate an interrupt? Well, I'm going to put mouse, so input device mouse, and I'm going to put right mouse button clicked for menu display. Okay, so it's a sort of an interrupt. Click the right mouse button if I want something else to happen. I'm interrupting a flow. Again, a little bit obscure. This question is quite horrid. 3 marks, 5 marks for A and B there. Yeah, horrid question. Question, oh, but there's 3 parts to this, another 5. So it's 10-mark question. Part 3. A processor is currently executing a program. The processor receives an interrupt. Explain how the processor manages the current program and the interrupt. Step 1. The processor gives the interrupt priority. If more than 1, it is placed in a queue. Okay? Processor checks priority. 1, 2, 3. The processor checks priority in terms of the next task. It will fetch and execute, okay, of these. Checks, interrupt, service, routine, the ISR, to determine what action to take. So basically it checks the interrupt service routine, the ISR, to determine what action to take in terms of the interrupt. What was the interrupt? What does the CPU need to do? Okay, and I'm just going to give you an example, e.g. key pressed on keyboard, an interrupt is triggered. Keyboard pressed on keyboard, Control-Alt-Delete, an interrupt is triggered. The ISR determines how to respond. For example, puts a pop-up screen up running Task Manager. So I think that would get us 5 marks. The processor gives the interrupt priority if more than 1, it places it in a queue. The processor checks priority in terms of the next task it will fetch and execute and therefore execute. It checks the interrupt service routine, the ISR, to determine what action to take. So example, Control-Alt-Del is pressed on the keyboard, an interrupt is triggered, the ISR determines how to respond. Okay, I think that will do, but again, not an easy, obvious question. Let's move on. Question 4. A student enters a uniform resource locator in URL in their web browser. Draw and annotate a diagram to show the process from the user entering the URL to the web browser displaying the web page. Okay, so we're going to basically be talking about how when we type in the URL, it's going to go to what they call a DNS server, a domain name server. That sends back the IP address. The IP address gets sent to the web server sends the web page back to our browser. So let's draw a computer, like so, and here, let's put Google in there. I'll put a little search bar there. Okay. So what this is going to do, we type in the URL here, and that sends a message, okay, to the DNS server, okay, domain name. So for example, www.bbc.com. Okay, this sends the URL back to the computer. So be that 15.36.56.72. Okay, I have no idea what it is. Okay, so it sends that back. Now then, the computer sends a message to a web server. The web server where this website, bbc.com, is hosted. Yeah. So let's send that back, 15.36.56.72. Okay. And then this is going to send this back, basically the web page. Yeah, it's going to go back to our computer. So we've got to annotate this. So browser sends URL to DNS server. Yeah, server sends back IP address. IP address sent to web server. Okay, corresponding web page sent to browser. Okay, so this then becomes bbc.com, okay, rather than Google. So that would be it. Okay, that would give us the full 5 marks. Is it 5 marks? 5 marks for this particular question. So that is how an URL works within the browser. Connects to the DNS server, gets the IP address. The IP address goes back to the web server, goes back to a web server. The web server sends back the website, sends back the web page. So the search window is then replaced by the web page we're looking for. Question 5, and they like to put these in now, these missing words, but they're not easy because you've got 1, 2, 3, 4, 8, 9, 10, 12, you've got 14 words to go into 1, 2, 3, 4 spaces. Okay, so you need to really have a think about this. Complete the description of digital currencies using the terms provided. Blockchains, changed, data chains, don't know what they are, centralized, deleted, encryption, passport, physical address, physically, records, timestamp, traced, transaction chains, virtual. Oh my word, I'm sure there's a few words in there you may not have come across before in terms of representing digital currencies. So a digital currency does not exist blank. Does not exist blockchains, does not exist, the correct answer there would be physically, yeah, rather than virtually. It does not exist physically. It's not tactile, it's not in your hand or in your wallet. It's what they call fiat currency. There's no pound notes or coins with it. Okay, so digital currency does not exist physically. It can only be accessed electronically. Okay, hence the word digital currency. Some digital currencies have digital ledgers called. Now, what are these called? These are called, no idea what a data chain is, it must be called a blockchain. Okay, and if you've done any research into this chapter, you will know all about blockchains. Okay, so that's 2 of the words. These are decentralized databases where each transaction is stored as a new set of data with a what? Well, it's going to be either a timestamp, I think, or it could be encryption. Not really. Okay, transaction chain, no. I think it's going to be timestamp. Let's have a look. These are decentralized databases where each transaction is stored as a new set of data with a timestamp, and it's linked to the previous set of data. Yes, timestamp. This means that transactions cannot be altered. Only new transactions added, which allows the location of the data to be, it's not deleted, and it's not changed, because we can't change it because it's just said there. So it must be traced. Okay, traced. Basically found again. Okay, question 5, 4 marks. Well, look, we've moved on now to the to robots. So question 6. Okay, a self-driving tractor sows seeds and harvests crops for a farmer. The self-driving tractor moves automatically through the field, turning at each end and stops when it is finished. One reason the self-driving tractor is a robot is because it is a mechanical structure that includes wheels, an engine, and a framework. Give one other reason why the self-driving tractor is an example of a robot. Well, because it's being told to go up and down the field, so you've got the field like this. So basically the robot's started here and it's gone down and round and down and round and down and round and down and round until it gets to the bottom and it stops. It's basically been programmed to do that. Okay, it might have some kind of sensor on it which tells it where the end of the field is and to turn round, or it might have go a distance of this, turn round, go a distance of this, turn 180 degrees. So basically it can be programmed. It is programmable. Okay, that gives 1 mark. I mean, you could put it's powered by electricity, but I think that's enough. It's programmable. B, and this is worth 5 marks, is a big one. So I'm looking here. What I would generally do is look for 5 bullet points. So let's have a little look at this. If a person is detected within 3 meters whilst a tractor is moving, okay, so if a person, let's say a person stood here, if a person is detected within 3 meters whilst a tractor is moving, the self-driving tractor must stop. Okay, so this tractor here must stop. Explain how an infrared sensor, microprocessor, we're doing about sensors now, it's a sensor question. Explain how an infrared sensor, microprocessor and actuator must be used to stop the self-driving tractor if a person is detected within 3 meters. Okay, the sensor question. It's good to draw a picture of this, and I've sort of drawn a picture here. So let's go down here. Okay, Sensor sends signal data continuously back to a microprocessor, okay, or computer. All the time it is sending, as it's moving along up here, it's sending data back. The infrared sensor saying it's clear, it's clear, it's clear, it's clear, it's clear all the way around until it gets to here and say, oh, the data's changed, it's now not clear. So sends data continuously back to the processor. Microprocessor checks data against stored data, usually in a database. Okay? If the data changes, e.g. an object appears within 3 meters, a signal is sent to an actuator, or in this case, the brakes of the tractor. Tractor stops. If signal continues to be greater than 3 meters, nothing happens. Tractor continues. And then I'm just going to put here the process is continuous until turned off. So that would be for 5 marks. Hopefully looking for sort of 5 bullet points. Okay, and then for 2 marks, identify one other sensor that the self-driving tractor might use and how will it use the sensor? Well, you're not going to use a pressure sensor or a pH sensor, but you might use a light sensor to turn the headlights on and off. But then if it's driven by a robot, then would the robot need lights on? So not necessarily. I would say a proximity sensor. And what does that do? Basically, very much like an infrared sensor, detects the end of the field and turns the tractor 180 degrees. Okay, so that would be the best option there, and that's 7 marks. So 8 marks for question 6. Okay, but it goes on. Okay, for part C, explain the drawbacks of a farmer using a self-driving tractor to sow seeds and harvest crops. A self-driving tractor is going to be expensive. So what I would put in here is the setup costs. Setup costs will be, we'll put expensive. So that's the first one. Okay, so explain the drawbacks. Along with that, also maintenance costs and servicing may be high. Okay, so there's some big expenses at the beginning. So setup costs will be expensive. Also maintenance and service costs may be high. Training costs on using new equipment, i.e. the tractor. I'll put one more in. Farmer may now need fewer employees. Okay, so unemployment. Okay, so setup costs will be expensive. Also maintenance and service costs may be high. Training cost on using new equipment for the farmer. Farmer may now need fewer employees, so there's going to be an unemployment. Okay, part D. The self-driving tractor has an inbuilt expert system that the farmer can use to solve any errors with the tractor. Identify 3 components of an expert system. Well, I'm going to try and draw this for you. Try and draw it fairly small. You've got the user, or the farmer in this case. There he is. And the farmer needs some help. The farmer wants to ask for help. So he's going to input into a user interface. He's going to ask a question. Yeah. The user interface is going to talk to what they call a rule, or what they call an inference engine. That in turn is going to talk to what they call a knowledge base. So the farmer is going to manipulate a user interface, which is going to talk to a rule or inference engine. The inference engine is fed by a knowledge base, okay? But the knowledge base is fed by experts, okay? Experts in that particular field. So experts in this case, driving and programming and using a self-driving tractor. Okay, so 3 components. We've got obviously a user interface. Okay, we've got a rule or inference engine, and I'm going to put in here a knowledge base. Okay, we could have experts as well to give us the full marks there. So E, that was for 3 marks. E, at the end of each day, the self-driving tractor transmits the data it has collected to the farmer's computer in their house. The transmission uses an echo check, Describe the role of the self-driving tractor and the farmer's computer in the echo check. So basically, how does an echo check work? Let's have a look. Data is sent to computer. Data from tractor, let's draw a little tractor, yeah, is sent to the computer. Okay, but because it's an echo check, the data is sent back to the tractor to make sure that the data that's been sent to the computer is the same as what's been sent to the tractor. So it's basically just checking to see if if the information has remained the same. So there's my little diagram, which potentially could get us 1 mark, these 2 arrows. In fact, I'm going to put sent back. So same data is sent back to the tractor. Tractor checks both sets of data. Okay, the data sent and the data received. If the data is okay, then the tractor sends confirmation is okay. Basically the same. Okay, so that's it. Same data is sent back to the tractor. That's the echo. The tractor checks both sets of data. The tractor sends confirmation data if okay, if the same. It might transmit or transmits error message if it's not okay. That is it for that. That's 3 marks. Okay, oh my word. So we've got a parity block here. Another method of error checking is a parity block check. The table shows 7 bytes. Here we go. 1, 2, 3, 4, 5, 6, 7 that are transmitted using odd parity. The parity bit has been completed for each byte. Complete the parity byte for the data. So we've got the parity bit here, and we've got the parity byte. So all we've got to do here is make sure that these numbers add up to odd numbers. So we might need to put a 1 or a 0 in each of these boxes here to make sure that they're odd. Okay, so this is what we're talking about here, odd parity. So 1 plus 1 plus 1 plus 1 is obviously 4, so we need to put another 1 in there to make it odd, to make it 5. 1, 2, 3, 4, 5, so put a 0 in there. 1 in there, which was obviously an odd number, 0, again, a 0. 1, 2, 3, 4, so that needs a 1 to make it 5. 1, 2, 3, 4, 5, a 0 in there. 1, 2, 3, 4, let's add a 1 in there. And 1, 2, 3, that's obviously odd. So that would be our parity byte. We're basically just totaling up each of these columns to make sure that they are adding up to an odd number. Okay, so that's the easiest, in my opinion, that's the easiest 3 marks you can get on this paper. So what have we got? Question 7. Is there many more questions after this? Question 7, question 8, and that's it. Okay, let's carry on. So question 7. Data is transmitted using the internet. The data is encrypted before transmission. State the purpose of encrypted data. What's encrypted data doing? Basically, if the data is hacked, yeah, if a hacker tries to get in, intercepted, it cannot be read or understood. So that would get us easily 1 mark. This 4 marks now though. Yeah. Describe the differences between symmetric and asymmetric encryption. So asymmetric and symmetric, it's all about using what they call a key. Symmetric uses 1 key, asymmetric uses 2 keys. So that's a shared key there, and here we've got 1, and then we've got another key for asymmetric, which is generally a public key, yeah, and we've got a private key. That's a difference. So S for symmetric and A for asymmetric. 1 key, 2 keys. So symmetric uses 1 key, a shared key, 1 mark. And we can put this both encrypts and decrypts the data. I think that would get us 2 marks. Now, so that's symmetric. Asymmetric uses 2 keys, okay? And these I've just said public and private. Okay, so I would say that would be my 3rd mark. But what can I say about these 2 keys? The public encrypts the data, okay, but the private decrypts the data. So which is the better one? I would just put here more secure. Okay, I think that's enough for that. Okay, part B. The data is transmitted using packet switching. Identify 2 items of data contained in a packet header. Okay, so I've got my packet, I've got my header. The header would contain where the packet is going to go. Okay, so the destination, IP address, because remember everything's run on IP addresses when it comes to packet switching. So the destination address, but it also needs to have the sender. Who is sending it? The sender's IP address. Each of these packets, though, unique number. If you want to include that, yeah, this is the data. There's the data in there. This is the header. Yeah, unique number. Give the purpose of a router in packet switching process. Well, the router contains which direction the packet's going to go across a network. So let's put controls route, hence the name router, route the packet takes going across a network. Okay, basically from one device to another. Controls, it chooses the most effective route. I think that will do for that. So is this the final question? Question 8. Convert the denary number 236 into hexadecimal. Okay, what is the best way of doing this? I'll show you a couple of ways of doing it. 256, if we do that as 116, 16 times 16 is 256, so it can't be any of those. So we've got to basically say how many 16s go into 236, and we're not allowed to use a calculator, remember, in our exam paper. So this might be the most difficult way. 236 divided by 16. 14 16s equals 224. Okay, so that means we've got 12 left over. So I'm going to put 12 ones in there. So 14 slots of 16 add up to 224. And of course, 1 times 12 equals 12. And that would give us 236. And we know, if I go down here, we've got the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we've got A, B, C, D, E, and F. 14 would be E, and 12 would be, if 10 is A, 11 is B, C would be 12. So the correct answer would be E, C. Okay? Now you might think, oh my word, that is ridiculously difficult. Yeah, in terms of converting it this way. So what you might want to do, and I'll show you this here, obviously the working space I've used at the top, but I'm going to convert this number into binary. 1, 2, 4, 8, 16, 32, 64, 128. What I can do with this, obviously the next number would be in the sequence would be 256, because 128 doubled is 256. So I know I can do this in an 8-bit register. So I'm going to say there's one lot of those. Let's just go here. 236 minus 128 would give me 108. Okay, so that means there's one of those. So 108 take away 64 would give me 44, which would be one of those. Yeah, 44 take away 32 would be 12. So none of those. One of those, one of those, one of those, none of those, none of those. So that would give, this is the binary number for 236. Now what I can do is I can split this into 2 nibbles. Okay, I'm just going to change this to 1, 2, 4, and 8. So if I add these up, 8 plus 4 plus 2 would give me 14, and 8 plus 4 plus 0 would give me 12. Okay, which is the same as this and this. And I go onto my little chart here, and I can see that 14 equals E, and 12 equals C. So that is my correct answer. Okay, but it's only for 1 mark, but that's one way. That's 2 ways of doing it. You may not have done denary to hexadecimal. So convert denary to binary, use the nibble method like I've done here, and you can get that answer there. Give one benefit of using hexadecimal instead of binary in terms of representing data. Well, this is good because you can see there's 8 characters in the binary number for 236, whereas there's only 2 characters for hexadecimal. So obviously it takes up less room. Okay, so I'm going to put here takes up less space. It's also, you might see this, easier for, I'm going to put humans to read. That's basically what I would put for that. Okay, now then we've got 2's complement. 2's complement can be used to represent positive and negative binary integers. Convert the 2's complement integer into denary. Show all you're working out. Now there's several different ways of doing this, but basically if I go put my working out here, 1, 2, 4, 8, 16, 32, 64 minus 128. So we've got one of these. So we're starting off with minus 128. No 64s, but we've got a 32. And we've got a 16. We've got no 8s, we've got a 4, we've got a 2, and we've got a 1. So basically what I'm going to do is add these numbers together, yeah, and then add them to the minus 128 and see what number I get. So 32 plus 16 equals 48, and then I've got 48, and then I've got 7 there. So my answer there would be 48 plus 7 would give me 55. So minus 128 plus positive 55 would give me negative 73. So this is basically how I would do that. Whatever numbers I've got here, yeah, add them all up and add them to minus 128. If you take 55 away from 128 and put a minus number in front of it. Okay. Next one, convert the denary number 45 into an 8-bit 2's complement integer. Into a 2's complement integer. Okay, so obviously the first number is going to be 0 because it's a positive number. So let's go with this. 1, 2, 4, 8, 16, 32, 64, minus 128. Okay, so there's none of those. There's none of those. We've got one of those, yeah, which is 32. 32 plus 16 would give me 48, so there's none of those. 32 plus 8 would give me 40, so there's going to be one of those. 44, none of those, and one of those. Okay, so the correct answer there would be 0, 0, 1, 0, 1, 1, 0, 1. And then finally, this is the final question. Logical shifts are performed on binary integers. State the mathematical effect of a right shift of 4 places on a positive binary integer. Well, a right shift, for example, if I take this number here, yeah, if I take this number at the top, 0, 0, 1, 0, 1, 1, 0, 1, and I do a right shift 4 places, so I'm going to basically take, if I start with this 1, I'm going to go 1, 2, 3, 4. Okay, we know that this number here equals 45, but we're moving 4 spaces. So basically, I've gone from, I'm going to add zeros here, 1, 2, 3, 4, 5, 6, 1, 0. So basically, that's gone all the way down, yeah? Move that all the way down. So this 1 is now here, this 0 is now here. So I've got a number of 2. Okay, so basically it's going to be a less number equals 2, so a lower number, so we're going to do a divide. Okay, and in this case we're dividing by, divide by 16 divided by 2 to the 4. Okay, 2 to the 4, we're basically moving down 4 spaces. I think that would get us 2 marks. Okay, so ladies and gentlemen, that is it for this paper. February-March 2024, paper 1. That should give us full marks. Okay, thank you very much indeed for watching. Join me very, very soon for paper 2. Okay, until then, bye for now. Thank you. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.